All right, so let's do, I did number 4, so let's do problem number 5.
Is it posted?
Yeah, number 4 is posted.
Stop.
Problem number 5 said the positions of two particles on the x-axis are, this is a parametric equation, so this is the x-axis, so this is a linear model, so it doesn't go up or down, it's just left or right. And I suppose if you wanted to, you could even write it this way. And it really functions of time. So it would be something like this, where this is the x-axis and this is time. And so the position of the particle for S1 is just sine of t. So S sub 1 is sine of t. And then S sub 2 is equal to sine of t plus pi over 4. And the sign of t represents the position represents the particle. So these are oscillators. It's very similar to like if you were to measure the distance of an electron from the center of the molecule or whatever. Electrons will go into different energy states and they oscillate back and forth. That would be one example. So anyways, the position of the two particles are represented by these two functions, and we measure it in meters. The distance is in meters and the time is in seconds. And then it says at what time in the interval from 0 to 2 pi do the particles meet?
Wait, we skipped.
We skipped 4. I already did 4 and I posted it. I can play it for you guys after this one. But what we're looking for is where do these two particles meet? Now there's a couple of ways that we could do this function. What are we really looking for?
What's it called? Intersection.
An intersection. So that's the easy way. What's the calculus way to find this? Huh? Do you guys remember what section this is? So let's do the easy way first. All right. Now these are technically parametric equations, but do I need to do parametric equations to figure out where they cross?
No.
No, not really. Right. So I could just graph these things, right? So if I were to come in and just do like sine of t or sine of x, and then if I do sine of, oops, let me clear that out. If I were to just do sine of, what was it, x plus, was it pi over 4?
Yeah.
Like that? Now what do I need to double check on my calculator though before I graph this?
That is in radians.
That it's in radians. So I'm going to come in here and I'm going to check and make sure that it's in radians, and it is. What else do I need to do? We said that t needed to be from 0 to 2 pi. So I suppose, since sine never gets bigger than plus or minus 1, I could set it up like this. And I could say x goes from 0 to 2 pi. And my y value goes from, I'm going to say negative 2 to 2. Okay? I'm going to graph all of them. So there's my sine function, one cycle from 0 to 2 pi. And then there's my second sine function, which is translated horizontally by a factor of pi over 4. And so what we're looking for are the two intersections. So I can just hit second trace and go to 5 for the intersection. And then I just need to move my cursor along the path of the first curve. So I get pretty darn close to the second curve and hit enter. And it'll say second curve, guess, yep. Now it gives me x is 1 over, or 1.17. Does anybody know what that is? Can anybody take a guess what that might be?
Over 8 pi over 3.
Let's write it down. This occurs when t is equal to 1.17. And we all know that we need to convert that to pi over something, right? Now, I'll tell you a little trick. If this is pi, and this is pi over 2, then it has to be less than pi over 2. It's probably pi over 3 or something like that. I don't know. We'll figure it out in a second. Let's find the other intersection. So now to find the second intersection, I do the same thing. I hit second trace, and I'm going to choose intersection for 5, and then I move my cursor over. Oh, I kind of screwed that up. Let's start over. Second trace, hit 5, and I just need to move the cursor over to the second intersection. And I got 4.31. Okay.
Yeah.
Now, what do you think the answer is?
11 over 8 pi.
Is it?
It's A, yeah.
It's A.
How did you get that though?
Because she's not embarrassing.
Oh!
No, I had this done.
What did you
Man,
say?
you might have been in that courtesy mode in that bus today. Courtesy mode.
Oh, she wasn't a courtesy mode.
Got
Yeah, that's one way you could do it. Like, I would say that because it's pi over 4, that you and then
It's a good day.
because it's pi over 4, you would have to have a common denominator. In other words, the denominator would have to be divisible by 4. So C would definitely be out, and I think D would definitely be out. So yeah, you could just guess and check. So one way to verify that, just to make sure, is if I hit trace, I might do something like 3 divided by 8 times. I think I screwed this up. I should have done 3 pi divided by 8. No, it worked out. Oh, that's right, because order of operations was left, right? So 3 divided by 8 times pi was one of the solutions. And then what was the other one? It was like 11 divided by 8. So if I said 11 pi divided by 8, that would give me the other intersection.
Udder.
So the answer is A.
Let's go visit a dairy farm.
Wait, so how did you know that it was the 3 pi? I meant the 3 over 8 and 11. I know you said like guess and check, but how do you get it from the 1.17 and the 4.31?
Well, 3/4 we know is 0.75, so that's not it. And 11 over 4, we should know that. What is that? 2.
Well, like 11.
2.75 or yeah,
Oh, so you
2.75.